All right, this is Mr. Gilman. Today we're going to talk about scale factors, and they're a little different than scales because a scale factor specifically has to be in the same units on both of them. All right, so that's the big difference. We're going to use these scale factors to solve problems. Okay, the scale factor is written as a fraction in simplest terms. Now, these ratios need to have the same units. So if I said 1 to 2, that would really be the same as saying 1 over 2. They mean the same thing, they're just written different ways. We're going to use the fraction form. Okay, so if it were something like 2 to 4, for instance, really that's 2/4. I wouldn't write 2 to 4, that wouldn't be my simplest terms. I would say 1 to 2. All right, so just make sure that we're reducing our fractions down all the way for our scale factors today. All right, the really big deal that we have scale factors have the same units. Okay, it's a really big deal. So for our first example here, all it says is find the scale factor of a model sailboat if the scale is 1 inch equals 6 feet. So before I do anything, I'm going to write this little fraction here so we're clear on what the scale factor is. So what we have here is the model compared to the actual object. All right, and that's really important. We have the model compared to the actual object. In this case, every 1 inch on the model represents 6 feet on the object. Okay, but unfortunately a scale factor must have the same units. And right now I have inches comparing to feet. So really what I want is 1 inch compared to how many inches is 6 feet. Well, I know that for each foot there's 12 inches. I could add all those 12s up, or I could just multiply 6 times 12. I know that 1 inch to 72 inches. So my model to my actual object, if I'm comparing them, my scale factor would be 1 inch on the model represents 72 inches on the actual object in this case. So I could say that my object is actually 72 times as big, the size, 72 times the size of the model. Okay, so the original object, or the actual object I'll say, because for every 1 inch on the model, the actual object is 72 inches. So we could say the actual object is 72 times the size of the model. Okay, so the scale factor would just be 1 inch over 72 inches. All right, again, it says what is the scale factor of a model car if the scale is 1 inch equals 2 feet? So really similar to the one we just did. I'm going to start with saying, okay, the model or the scale, the little version of the car, compared to the actual car. I'm going to just call it an object. The model represents 1 inch for every 1 inch, and the actual car would be 2 feet. But for a scale factor, they need to be in the same units. So I know that for each foot there's 12 inches, so I could add those up, or better yet, I could just say 24 inches and just multiply. Okay, so in this case what it means is for the model compared to the actual object, 1 inch compared to 24 inches, I know that the actual object is 24 times the size of the model. All right, and that's what that scale factor means. Okay, for every 1 inch on the model, there's actually 24 inches represented in the actual object. Okay, so it's important to understand what the scale factor is saying. All right, and depending whether you're comparing model to object or object to model is going to change what your fraction looks like as well. Okay, so we're going to use a scale factor to solve problems. And to do that, think of your unit rate in terms of the model compared to the actual object. So it's kind of a big deal. Okay, we already kind of talked about that a little bit. Let's take a look here. It says example 3, a model rocket was built using a scale factor of 1 to 15. If the actual rocket is 9.9 meters, what is the height of the model in millimeters? Okay. When we look at example 3, there's some important things that stick out to me. It says a model rocket was built using a scale factor of 1 to 15. That means, what this is saying, this is the model to the actual. This is saying that the actual is 15 times the size of the model. All right, and so we have this fraction, 1 to 15. Okay, so every 1 centimeter, it's 15 centimeters. For every 1 meter, it's 15 meters. But this time, in this case, it says that the height of the actual rocket is 9.9 meters. What is the height of the model in millimeters? So first thing I need to do is I need to figure out how much, I'm looking for the model's units. I need to know how many millimeters are in a meter. I know there's 1,000 millimeters in a meter, so instead of writing 9.9 meters, I'm going to go ahead and convert that right away and take 9.9 times 1,000. Now we know our metric system, we just need to really move the decimal place 3 spots. 9,900 millimeters. Okay, so that's the actual height of the rocket, is 9,900 millimeters of this rocket. So I think it's time to start ahead and start setting up proportions. Okay, and it's what it is a comparison of two ratios. If I know the scale factor is 1 millimeter for every 15 millimeters, I need to know how many millimeters the model is, and I can compare that to 9,900 millimeters. Okay, and so what I've got here is a nice, what we call a proportion. It's a fraction that equals another fraction. I know you've done proportions in the past, but we haven't done them yet this year, so I want to make sure we're clear on them. Each part is called a ratio, each fraction itself. When we compare two ratios with an equal sign, we call it a proportion. We've learned how to solve equations through clearing fractions and doing inverse operations, that type of thing. Well, there's some special relationships, and I know you've done it before because I hear you say this a lot. Cross multiplying. When it's a fraction equals a fraction, you are allowed to cross multiply because it's the same thing as clearing the fractions. I'm going to multiply both sides by 9,900 to cancel out the 9,900. And I would multiply both sides by 15 to cancel out the 15. Well, really what's happening is I'm just cross multiplying. Okay, so I know when I cross multiply, 9,900 times 1 equals 9,900, and that equals 15x. Now if I'm trying to find my missing value, I can do it quickly by saying 9,900 divided by 15. Let's see here, 60 is 4, 75, 90, so we'll say 6 minus 90 equals 9, 0, and 0, 660. So I'm going to say that 660 millimeters is the size of my model, and 9,900 millimeters is the size of my rocket, and that would make sense. Okay, so we're using proportions today mixed in with our new scale factors. All right, so let's take a look at another one here. It says a backyard playhouse was designed after a real house using a scale factor of 3 to 5. Okay, that's my scale factor, meaning for every 3 inches, it's 5 inches on the real thing. For every 3 feet, it's 5 feet, depending on what our units are. In this case, it says if the ceilings of the playhouse are 6 feet tall, how high are the ceilings in the actual house? Okay, well, in this case, it says, and remember, we're comparing the model to the actual. Okay, if the ceilings in the playhouse are 6 foot tall, how high are the ceilings in the actual house? So, well, it tells us that in the model, the playhouse are 6 feet tall. How long or how big are the actual house ceilings? Well, let's figure it out. Since we don't know how far, I'm setting this proportion up. I'm comparing model to model, actual to actual, and I don't know the actual height of the real ceilings in the actual house. What I'm going to do is this. I'm going to say this first fraction represents the scale factor. The second fraction represents the actual dimensions, we'll say. Okay, so now if I want to cross multiply, I can because I have a proportion. So I'm going to take 3 times x, 3x equals 5 times 6, 30. And now I can solve x equals 10. And I think that we could probably have done that easier the other way from yesterday, but it's good to practice these proportions. Okay, I could have said, well, I know that 3 turned into 6, it got multiplied by 2, so I know 5 times 2 would be 10, and got my answer quickly like that. But it's important to start working with these proportions because they're going to be important here soon. The next example says a dinosaur figurine was built using a scale factor of 1 to 42. If the actual dinosaur was 12 1/4 feet tall, what is the height of the figurine in inches? Ooh, okay. So this is a tricky problem too. It's like the example 3. Our scale factor is 1 to 42. That tells us that the actual is 42 times as big. Now it's asking us about the figurine in inches. So before I do anything, I better figure out how many inches we're actually talking about, because in a scale factor, we need to know that they're the same exact increments, okay, the same units. So 12 1/4 feet would really be like saying 12 1/4 times 12, because there's 12 inches in each foot. So instead of doing that, let's just do it the long way here. 49/4 times 12. 49 times 3 is 147. So we're going to say we're comparing it to 147. Okay. Remember, the top one is the model. The bottom part is the actual. And so the actual is 42 times that, so 147, actual, and we need to know the height of the figurine. So this is what we don't know, okay? So if I cross multiply, because I have this nice proportion here, what I can do is 147, when I multiply 1 times 147, equals 42 times x. And now it's just a matter of dividing and simplifying. 147 over 42. And so really what I should do is, that's not a very good answer. I should write that as a mixed number. So I'm going to say x equals 3, and 3 times 42. Let's see, that'd be 42 times 3, 6, 12, 126. That leaves 21 left over. So 3 and 21 42nds, or really it would be x equals 3 and 1/2. So in this case, we would have a 3 1/2, 3 1/2 inch model. All right, 3 1/2 inch model. If I multiplied 3 1/2 inches times 42, like my scale factor says, it should give me 147. Looks like that's it for today. So the last thing I want to add in here, find some blank space on your paper. A ratio is a fraction or comparison. A proportion is fraction equals fraction. Okay, we're going to say that solving proportions can be done by cross multiplying. All right, so I just want to make sure we're clear. A ratio is the fraction itself. So each of these separately is a ratio. But together, when we're comparing them, it makes a proportion. All right, we're comparing two ratios. That's it for today. We'll probably do 1 or 2 in class when I see you tomorrow.